Hi everyone, welcome to my seminar presentations. It's me Srijesh R, second is CSE. The topic what I am supposed to take is memory systems, which is a basic concept, and semiconductor RAM memory. I will begin with memory system. We'll start with the basic concepts, and I will further move on to semiconductor RAM memory. This is a small topic. Which in detail lot of topics subtopics which we have to discuss, so we will go there. I just made a small note for that, so we will move with this. So here we will discuss about basic memory circuits, which is the which will be the main concepts of the memory systems, will be the basic memory circuits and how the memory is organized, and we will also discuss the cache memory and the memory access time regarding something like that, and also we will discuss about virtual memories and magnetic disk, optical disk, something like that. We have a lot of basic concepts, and not only this, we will also discuss topics out of this main sector. As all we know, program and the data which we operate, we know for a computer to operate it requires two things, program and the data. So both are held by memory, as we know. For all, memory is an virtual, or what we call as an essential part of the computer. So without a memory, we cannot do anything, as we all know. Also know there's another point regarding memory, is the execution speed of the program. It's highly dependent on the speed of the instruction and the data transfer between the processor and memory. This times the execution speed of any program or the performance of the system is directly regarding with the speed of the memory they are using. I know a lot of friends who are suggesting SSD, which is solid state drive, which is more quicker or more faster or more efficient than hard disk drives nowadays, which most of them will be gamers or those who do video editing, and those people who requires a lot of memory transfer per second. That's another concept. What I want to say is execution speed of a program is highly dependent on the speed of the not only on the performance of the memory, but the memory performance is a factor on the execution speed. If the memory doesn't supply the program and the data on time, it will also it will depend on the execution. So that's all, and it is also important to have a large amount of memory for large use of facilitate program which use large amount, like if you are playing a huge games like GT and FS, we know that we need a heavy amount of or a large amount of memory is required, like here just directly proportional, directly assigned to the RAM actually. As we know, we have, before we play some games, there will be some specified system requirements. Just I will show you, like system requirements of just load doc. Okay, just system log for just the game, and first look at 8 GB RAM. As you know, the large amount of memory is required for the programs that requires huge amount of memory. So that's the basic concept. What is an ideal memory solution should be like? If you're talking about memory solutions, what should be it like? What are the properties should be a ideal memory solution should have? The memory should be fast. That means the data retrieval or data insertion, or what we can call read-write operation, that we should quickly retrieve our data and quickly read out, quickly write out data. So read and write operation should be quick. The storage capacity should be large also, and the data the solutions would be inexpensive. So this is the three factors regarding the ideal memory solution. Ideal memory solution should be fast, large, and inexpensive. That means cheap. So unfortunately, it's impossible to meet meet all three requirements. Like if we consider the fast as a factor, we can go with the SSD or M2 drives, which is expensive. Also the storage capacity is also low. Yeah, there is a the SSDs are available with 1 TB or 2 TB capacity, but it costs a lot. Okay, even a 250 GB SSD I think cost around 7 to 10k, and the same you will get a 1 TB hard disk for a rate of 2 to 3k. So if we go for the storage capacity, we can merge all these requirements right here. So as we know, speed and size as increases, the cost will be directly proportional. As speed and size increases, cost also increases. So that's just a comparison. So to solve the issue, we have more creative ideas, and we are developed a reasonable, we are developing our technology, so we are developing our architectures to solve this all out. The basic component of okay, so let's check it out. So the basic components. So I think it's all clear about up to there. We have discussed the importance of memory and execution speed and ideal solutions. That's all. And so we are again with the basic components. So the maximum size of a memory that can be used in any computer is determined by the addressing scheme. So this is the main concept. This is the idea everyone should know. The maximum size of a memory that a computer can be addressed or can be utilized is depending upon the addressing scheme of the system. Like a 62-bit computer can generate only a 62-bit address that is capable of addressing 2^16 address, that is 64k memory locations. So a 60-bit computer can't address more than 6k locations, so it's limited to up to there. And same for 32-bit machines, they can generate up to 32-bit address capable of addressing 2^32, that is 4 GB of memory locations. So after the 4 GB they can't address that. So okay, this is the limitation right here. And also for the 40-bit machines, it's 2^40, that is 1 terabyte location. So that's the mechanism, or that is what the statement clearly says. The maximum size of a memory that can be used on a computer is determined by the addressing scheme. So it's depending on the, it is talking about the main memory actually. So don't confuse the okay. So as we know, we are using 64-bit systems right now. Mostly it will be 264-bit systems or into 86 architecture right now. Also we have much more address locations. So even there is lot of 2^32 4 GB memory systems. So that's the topic we are leaving there. So the number of location represent the size of address, or the space of the computer that can be addressed, as we said earlier, address space. Okay, so most computers are byte addressable. That means, as we know, 1 byte is equal to 8 bit, and most of computers are byte addressable. That we will address that byte, specify the byte. And so the memory is usually designed to store and retrieve data in a word length quantity. So actually even though the systems or computer right now are byte accessibility, the data retrieval and data storing both are done in the word length quantity. So what is word length? The word length of a computer is the number of bit actually stored or retrieved in a one memory access. So how many bit or how many bits can actually the system can retrieve or system can store at a one memory cycle, it is known as the word length of the computer. So it's depend on system to system. Okay, that's the system's code. That's depend on the system. Okay, so let a byte address system generate 32-bit address. When 32-bit is sent to a processor, that bit will be determined as. So we will discuss it later. Just okay, so I think up to there it's all clear. So we will move next topic, next video. Okay, thank you.